myself Somshekar. So today I'm going to introduce Lab 4, application of maxima and minima of function of two variables, Taylor series expansion, and L'Hospital's rule. L'Hospital's rule. So first we will discuss maxima minima problem. Find the maximum and minimum value of f of x comma y is equal to x cube plus 3x y square minus 15x square minus 15y square plus 72x 72x. So first we need to find the first order derivative del f by del x, differentiate f with respect to x. So del f by del x also we can denote it as f suffix x. So x cube differentiation is 3x square, x differentiation 1, we get 3y square, x square differentiation is 2x, 15 to the 30 minus 30x. So this is 0 as y is independent of x, and 72x, x differentiation 1, we get 72. Similarly, f differentiate f with respect to y. So del f by del y, so we denote it as fy, that is equal to, so y square differentiation is 2y, 2 into 3, 6xy. So y square differentiation is 2y, 2 15 is 30, it is minus 30. After getting first order derivative, we equate to first order derivative to 0 to get nodal points. So equating these two to 0, 3x square plus 3y square minus 30x plus 72 equal to 0. Taking 3 as common factor, x square plus y square minus 10x plus 24 equal to 0. Call this equation as 1. Now 6xy minus 30y is equal to 0. So call this equation as 2. Consider equation 2. 6xy minus 30y equal to 0. Take out 6y common factor, x minus y. 6y into x minus y equal to 0. So transfer this 6 to LHS, RHS to 0. So y into x minus y is equal to 0. Equate each term to 0. X minus y equals 0, y is equal to 0. X equals 5 and y is equal to 0. Now put y is equal to 0 in equation 1. So on putting y is equal to 0 in equation 1, we get x square minus 10x plus 24 equals 0. On factorization, we get x minus 4 into x minus 6 is equal to 0. X minus 4 equals 0, x minus 6 equals 0, x is equal to 4, x is equal to 6. So on combination of y equals 0 and x values, we have two nodal points, 4, 0 and 6, 0. Next, we put x is equal to 5 in equation 1. So we get 25 plus y square minus 50 plus 24 is equal to 0. 25 plus 24 is 49. 49 minus 50 is minus 1. Y square minus 1 is equal to 0. Y square is equal to 1. Y is equal to plus or minus 1. So y is equal to 1 and y is equal to minus 1. So taking x is equal to 5 and y values on the combination. So 5 comma 1 and 5 comma minus 1 are the two nodal points. So we have got 4 nodal points, 4 comma 0, 6 comma 0, 5 comma 1 and 5 comma minus 1. Now we shall discuss that discriminant AC minus B square is called as discriminant. So if A is greater than 0, AC minus B square is greater than 0, then function f of x comma y is minimum value at this nodal point. If A is less than 0 and AC minus B square is greater than 0, then f of x comma y is maximum value at this nodal point. If AC minus B square less than 0, then f of x comma y is said to be saddle. This must be no. So what are A, B, C? So now we find the second order derivative. That is, so here is the first order derivative del f by del x. Differentiate this with respect to x once again with respect to x. So we get 6x minus 30. So we denote it as A. And similarly, the same first order derivative del f by del x is differentiate with respect to y. So on differentiating, we get 6y. So 6, we denote this as p. Next, differentiate del f by del y with respect to y again. So y differentiation 1, 6x, and here y differentiation 1, 30. So del square f by del y square, we denote it as c. So we are getting 6x minus 30. Now we tabulate the values. So nodal points on the first row along column wise A, B, C and discriminate values. So for a particular coordinate system, we got these values. Okay, so here A is less than 0. A is less than 0, and AC minus B square is greater than 0, then we are getting maximum value at this nodal point. And A is greater than 0. Okay, so and AC minus B square is greater than 0. At this point, we are getting minimum value. So A is 0 at these 2 points, 5 comma 1 and 5 comma minus 1, and also AC minus B square is less than 0 at these 2 points. So therefore, we got saddle point. So we need to find the maximum value for 4 comma 0. So substituting x as 4 and y as 0 in the given function. So on simplification, we get 112. So we need to find minimum value at 6 comma 0, and we are getting so it is 6 comma 0. Okay, so we get 108. Maximum value is 112 and minimum value is 108. Now we look into the program. So same problem we are taken here. Here importing SIMP module. Importing SIMP module. From that SIMP model, we are taken a variable sim. So this sim acts as a symbol. So or otherwise, we are importing sim from SIMP module as star also. Okay, so you can take any of the form. Now just I will look into from different form we are taken sim. I will show that also. Okay, so here we need two symbols x comma y. So sim dot symbols x y, that is stored in xy. So in third line we just write the problem statement. So x star double star stands for power, x cube plus 3 single star stands for multiplication, 3 into x into y, double star means y square minus 15 into x square means we put a double star minus 15 into, so we are putting single star, y double star 2 means y square plus 72 into x means, so we are putting single star. So differentiate f with respect to x. So sim dot derivative of f with respect to x. So we are adding to it this derivative. So that is storing dx1. So similarly, differentiate f with respect to y. So how to write sim dot derivative f comma y. So do it forcefully. So that is stored in dy1. So as we look in the manual evaluation of the problem, we are equating the first order derivative to 0, and we call up as two equation 1 and equation. Similarly, in the same manner, we have taken equation 1 and equation 2 here. Sim dot equation 1, so that is dx1 equal to 0. Sim dot equation dy1 equal to 0. That is stored in eq1 comma eq2. So on solving this equation 1 and equation 2 with for x comma y, so that is stored in solution, that is SOL. Print the critical points, or so print the critical points of solution. So here critical points are 4 comma 0, 5 comma minus 1, 5 comma 1, and 6 comma 0. Okay, so after getting a node of points, next we want to find the second order derivative. So differentiate this dx1 with respect to x again. So that is, we write it as sim dot derivative of f with respect to x twice. Do it, that is stored in dx2. So sim dot derivative of dx1 with respect to y, do it, that is stored in dxy. So mixed partial derivative, and differentiate dy1 with respect to differentiate, or you can write a sim dot derivative of y f with respect to y twice. So do it, that is stored in dy2. After getting this second order derivative, now we are taken for I comma j in solution. So let us denote this dx2 dot substitute x value as I, y value as j, and evaluate. We get a value. We are stored this as a. We are storing these values in a, and similarly dxy dot substitute x as a I, y as a j, and evaluate f, that is stored in b. So dy2 dot substitute x as I, y as j, so evaluate f, so that is stored in c. So we can write print a value 0, A value minus 6, A value 0, A value 0, A value 6. Okay. So similarly, so we put here P, and we have put here P. And we have put it C. Here we have put it C. Now just run. So A value 6, minus 6, 0, minus 6, 0, minus 6, 0, 0, 6, 0. Okay. So 6, 0, 6. Okay. Next, discriminate, we need to find AC minus B square. So if discriminant is greater than 0 and A is greater than 0, okay, if loop we have taken, if loop, print the function has minimum. This is the condition for minimum points. So f dot substitute x as I and y as j and evaluate f. That is stored in Q1. So print minimum value for Q1. So on printing this 108. So elif discriminant is greater than 0 and A is less than 0, then the function is said to be maximum. Okay, at this nodal points I comma j. So substitute x value as I, y value as j, and evaluate. We got maximum value. The maximum value here is 112. So elif discriminant is 0, less than 0, print it is a saddle point. Elif discriminant is 0, so print it needs further investigation. Okay, it needs further investigation. We got three types of points. One is maximum point, another one is minimum point, and saddle point. And the fourth one is not uh, uh, coming in this problem. Okay, so this is about the maxima and minima problem. Okay, so thank you.